Homework 20, question 8. In part A, we're asked to verify that the coordinates of A are 3, 0. We just need to substitute in the x coordinate and show that we do get the y requirement that we expect. So at x equals 3, I get y equals 3 squared minus a third times 3 cubed, which is equal to 9, take away 9, which is 0, as required. In part B, we're asked to show that the equation of the tangent to C at the point A is y equals minus 3x plus 9. We need to start by differentiating our expression for y. Dy dx is equal to 2x minus x squared. We're trying to find the tangent at the point A, so we need to plug in x equals 3. X equals 3, dy dx is equal to 2 times 3 minus 3 squared, which is equal to 6 take away 9, which is equal to minus 3. And we were expecting a minus 3 because the equation of the tangent given in the question is y equals minus 3x plus 9. We've got two options here. We can either use y equals mx plus c and substitute in a pair of coordinates, but I prefer to use y minus y1 equals mx minus x1. We know a point on our curve, we know that's a point 3, 0. So we can plug in y minus 0 equals m, the value we just found, minus 3, x minus 3. If I expand brackets and simplifies, that gives me y equals minus 3x plus 9 as required. In part C, we're asked to use our answer to part B, our tangent, and figure out where it meets the curve again. We find where two lines meet by setting them equal to each other, so we need to set our equation minus 3x plus 9 equal to the equation of our curve x squared minus a third x cubed. We want to multiply everything up by 3. Equations are much easier to solve when they don't have any fractions in. And then we want to rearrange our equation so that it's set equal to 0, and this gives us x cubed minus 3x squared minus 9x plus 27 equals 0. Now we have to solve this equation. Solving quadratics is no problem, solving cubics is a little bit harder. Fortunately, we know one of our solutions. We know that x equals 3 is a solution to this equation. If I divide by that factor, x minus 3, using some polynomial division, I can figure out what my remaining quadratic is, and then I can factorize that. When doing the polynomial division, I ask how many x's go into x cubed, and that is x squared, and then I multiply x squared by x minus 3 to get x cubed minus 3x squared. I then take away the line I've just created from the line above it. X cubed take away x cubed is 0, that one will always come out as 0. Minus 3x squared minus 3x squared, though, is also 0 in this case. And then I still have a minus 9x plus 27. Now ordinarily my next step would be to do my x squared term divided by x, but if I've got 0x squared, that's clearly going to give a plus 0x, so I can move on to the next term. Minus 9x divided by x is minus 9, minus 9 times x is minus 9x, minus 9 times minus 3 is plus 27, so if I do the subtraction once again, I'm getting a grand total of 0. I was expecting a 0 here because I knew that x minus 3 was a factor. Returning to my previous part, my cubic is now factorizing into x minus 3, x squared minus 9 equals 0. This is difference of two squares to give me x minus 3 all squared, x plus 3 equals 0. So my x coordinates are 3, which I knew already because that was my part A, and minus 3. I was asked, however, to find the... I was just asked to find the x coordinate. In some questions, you are asked to find the entire coordinates, and you'd have to find y. In this case, however, the x coordinate is enough. Part D asks us to find the shaded region R shown in the diagram above. This is the area between two curves. One of them is technically a straight line, but in mathematical terms that is still a curve. The way that I want to do this is I want to find the area underneath my straight line which gives me this triangle here, and then find the area underneath the curve, which is the white part, and if I take that second part away from the first part, that's going to leave me the shaded area that I'm actually after. To find the area of the triangle, the area under the straight line, I can do this by integration, but I could just do this by finding the area of a triangle, which is typically easier. It's a triangle in this question. In other questions it could be a trapezium. All I need to do to find the area of a triangle is to figure out the base and the height. Now the base is 3 take away minus 3. 3 from this point, minus 3 from this point, so it gives me a base of 6. And I have to multiply that by half. Now I need to work out what the y-coordinate of my point is. I can plug that into my equation of the tangent I found earlier. Y equals minus 3x plus 9. At x equals minus 3, I get y equals 9 plus 9, which is 18. So that's my height. That gives me half times 6 times 18, which is equal to 54. To find the area underneath the curve, I need to use integration. So I need to integrate my expression for y, the curve this time, rather than the straight line, which was x squared minus a third x cubed with respect to x, and I need to do that between my limits of negative 3 and 3. Biggest number on top, smallest number on the bottom. When I integrate, I add 1 to the power and I divide by the new power. Add 1 to the power, divide by the new power. And I now change my notation to square brackets, still with my limits. When I integrate between limits, which is called definite integration, I don't need to put a constant of integration. I can do if I wish, there's no harm, but it's extra writing that I don't need to do. And if I simplify this, this gives me between 3 and minus 3, 1/3 x cubed minus 1/12 x to the power 4. Now I need to substitute in these limits. I sub in the top number first, and then I substitute in the bottom number second, and I do the first one, take away the second number. So this gives me 1/3 times 3 cubed minus 1/12 times 3 to the power 4 minus 1/3 times minus 3 cubed minus 1/12 times minus 3 to the power 4. Okay, a third times 27 is 9. 1/12 of 81 is 81/12. That does simplify, but I don't feel the need to do it, which you'll see why in a minute. 1/3 of minus 3 all cubed is minus 9, and 1/12 of minus 3 all to the power 4 is once again 81/12, and the minus sign from there goes there. So I have 9 take away negative 9, which becomes 9 plus 9, which is 18, and I have minus 81/12 take away minus 81/12, which becomes minus 81/12 plus 81/12, and those disappear. Finally, R is my area under the triangle, 54, take away my area under the curve, 18, which is equal to 36 units squared.